Hello, this is Mrs. McTaggart. In this video, we are looking at the probability of joint events. So this is a probability of an outcome when there's two different things going on, like rolling two dice, rolling two spinners, things like that. This crops up quite a lot in National 5 applications of exam questions, and it all relies on you being able to list all of the possible outcomes in a little table. So what happens is, I'm going to start with the most simple example that they use quite a lot. When you roll two dice, obviously, you can roll a 1 and a 1, a 1 and a 2, a 1 and a 3. You can roll doubles and things. There's a lot of outcomes. So we list them. Now, depending on the question, sometimes I list these by adding them together. Sometimes I just list them as the little pairs, which is what I'm going to do here. So, for example, you can roll a 1. Oh, where's my pen not working? You can roll a 1 with a 1. You can roll a 1 with a 2. You can roll a 1 with a 3, a 1 with a 4, a 1 with a 5, a 1 with a 6. Do you see where I'm going here? Then I can have a 2 with a 1, a 2 with a 2, a 2 with a 3. I'm going to speed this up a wee bit. And here you go. So I paused and just filled them in. So you get the idea. So here are all the different outcomes. So how many different ways are there of throwing a dice? There are 36 different ways for your dice to land. Right, so I'm going to ask you lots of questions about this related on it. So I've got the diagram we use all the time on slides. So question 1 asks you, to get out of jail you need a double. So what is the probability of you landing a double? So your doubles are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So in the exam you would draw out all the outcomes in the table and highlight them or circle them somehow, just so you can clearly see what you've got. So there was 6 ways of getting a double out of a possible... Where am I writing a 6? Out of a possible 36 outcomes. And again, this simplified 6 times table takes that down to 1 in 6. So when you're trying to get that double to get out of jail, it's a 1 in 6 chance of getting that double. Same scenario. This time I needed 8 to land on Mayfair. You know everyone wants to land on Mayfair, don't they? What is the probability of getting that 8? It's actually not as bad as you would think. So the way you can get an 8 is you can roll... obviously a 4 and a 4, a 3 and a 5, a 2 and a 6. There's another 3 and a 5 and another 2 and a 6. So there's 5 ways of scoring exactly 8. So probability of scoring an 8 would be 5 out of 36, which then doesn't simplify at all. Here's a different question. I've taken this straight from a past paper. So what we've got is... we're trying out a game at Carnival. The game involves you flipping a coin and rolling a dice. To win, you must land on either a head of a coin, followed by an even number, or land on a tails, followed by a 1 or a 6. So before I even start reading too much about that, I'm going to draw all the outcomes. So I've got a coin. So a coin can either have a heads or a tails. And dice is the numbers 1 to 6. So 1, 2, 3, 4, 5, 6. So my outcomes are heads with a 1, heads with a 2, and so on. Heads with a 4, heads with a 5, heads with a 6. Tails with a 1, tails with a 2. So here are all my different outcomes. I'm then going to highlight the ways that I can win. So they said you can win with a heads followed by an even number. So that's heads, 2, 4, or 6 for a win. Or a tails with a 1 or a 6. So tails with a 1 or a 6. This is the most random question ever. However, it's not too bad. So I've circled 5 outcomes, 5 favourable outcomes for winning out of a possible 12 ways of the coin and the dice landing. So you have a 5 in 12 chance of winning on this carnival game. Roll up, roll up. Here we have another one. This time we're talking about 2 spinners. So the spinners are spun. I'm just going to move this to get a wee bit more room. To win a prize, we need to land on a blue or a green and an even number. So let's do our table of outcomes. So if I take the colours, we can land on a red. Oh, red's there twice, so I'm just going to write red, red. I've got a blue, a green and a yellow for short. And then I've got the numbers 1 to 5. So 1, 2, 3, 4, 5. So I can have red 1, red 2, red 3. Let's fill in this in quickly. Okay, so I've filled it all out. So let's read the question again. To win, we need a blue or a green and an even number. So my blues and greens with even numbers are, blues and greens are down here. So I can have a blue and a green 2, a blue or a green 4. Now I'm embarrassed to admit I haven't actually read this question properly. It says the probability of not winning. So I'm actually going to continue and get the probability of a win first. So probability of a win is 4 out of 25. So the probability of not winning, so probability of losing is obviously 25 take away 4 is 21. So 21 out of 25 chance of losing in this game. Oh, who's read the question? I nearly got that one wrong there. Right, one last for you. This one is about the lottery. So 2 parts to this one. So we have got numbered balls 1 to 32 in the lottery. And it says, what is the probability the first ball is a number greater than 25? So we're not including 25. So we're including 26, 27, 28, 29, 30, 31 and 32. So we've got 7 balls bigger than 25 out of a possible 32 balls. And that doesn't simplify, so that's part A done. Then it says 4 number balls are drawn and not replaced. So 4 balls have already been. What is the probability of the number 9 now being drawn out? And obviously that's assuming the number 9 hasn't already been. So first of all, 4 balls have gone, so we're now down to 28 balls. And the number 9, if it's still in there, is the only number 9. So it's a 1 in 28 chance of you pulling out the number 9 if 4 balls have gone. And that doesn't simplify either. So I hope this has helped. Thanks very much for watching. Bye-bye.